Hey boys and girls, so today we're going to be going over Unit 12, Lesson 4, which is horizontal shifts. I know yesterday we had gone over Lesson 3, which was vertical shifts. Okay, so vertical moves you up and down. Horizontal, which is what we're going to go over today, moves you left and right. So if I want to start off by just looking at the do now here, it says graph the functions on the same graph. All right, so if I look at the f of x function, it tells me that it looks like x squared. So I'm just gonna jump over to my Calculator X app, and just like we would do in school, I'm just gonna press the y equals, and I'm gonna type in x squared, okay? And then I'm gonna press second graph to look at my table. Now I know x squared is a quadratic, which means it looks like a parabola, which is a happy face or a frowny face. So I wanna have my table balanced, and that's something really important that we've gone over in class a ton of. So I can see here that when I scroll and I look, when x is -4 and when y is +16, that's where my table starts to be balanced because my y values start with 16 and end in 16, right? Then we have our 9, 9, 4, 4, 1, 1, and 0 is in the middle, all right? So this is the table that I want to copy over onto my paper. So I'm just going to move this out of the way so I can get those values down. All right, so again, I'm not going to include the -416 because that's going to go off my graph. So I'm just going to include a few points. I'm going to start with -3. So when x is -3, y is 9, and then I'm going to go from there. We have the point -2, 4, -1, 1, 0, 0. And then that's where our graph starts to flip. So now we have the point 1, 1, 2, 4, and then +3, 9. All right. And then I'm going to just go ahead and do the same thing for the g of x function. So I'm just going to go back to my little calculator here. I'm going to press y equals. I'm going to clear out what I already have. And now I'm going to type it in exactly how it looks on my paper. Parenthesis, x plus 5, close it, and square it. And then again, I'm going to go to my table. And I want my table to be balanced. So I got to look for values that will do that for me. All right, I don't know. All right, here we go. All right, so it looks like when I start out with an x value of -7, that's where my y values become balanced. So we have 4, 4, 1, 1, and 0 is in the middle. All right, so this is the table that I want to copy over onto my paper. So again, I'm going to start when x is -7. So we have the point -7, 4. And then I'm just going to go down from there, -6, 1, and then -5, 0. And then it starts to flip on me. So then I have the -4, 1, and then the -3, 4. All right, we're always looking for that balance, right? 4, 4, 1, 1, 0 is in the middle. Same thing with my f of x function. 9, 9, 4, 4, 1, 1, 0 is in the middle. And now I'm going to go ahead and plot both of those on my table, on my graph over here, because it says I want to graph both of them on the same graph. All right, so we have that point -3, 9. So we have -3, 1, 2, 3 to the left, and then up 9, and I'm going to plot. And then we have -2, +4, 1, 2, 3, 4, -1, 1, and then 0, 0. Okay, and then it flip-flops. We have +1, 1, +2, 4, +3, 9. All right, go ahead, connect those points. And then I'm just going to label this as f of x. Okay, and now I'm going to grab my red and graph my g of x function. So again, I'm going to start when x is -7 and plot when y is +4. So to the left, 7, and then up 4. 1, 2, 3, 4. And then again, we have -6, +1, and then we have -5, 0. And then again, it's flip-flopping. Then we have -4, +1, and then -3, +4. And then I'm going to go ahead again, connect those points, and then I'm going to label g of x, okay? And then the question says, after I graph both of them, how does the graph of g of x compare to f of x? So how is my blue comparing to my red? Well, it looks like I have to take the blue and I have to move it 5 units to the left in order to create that g of x function, that red graph. So I can even look at the points that I'm plotting and count them. I started at 0, 0, and I counted left to the left 5 units, and here I am. All right, same thing again. I'm at this point, negative 1, 1. If I go to the left 5 units, now I'm at negative 6, 1. All right, and then it goes from there. So it looks like I have to take my f of x function and I have to move it 5 units left. All right, and that's going to give me the g of x function. Cool. All right, and then this is leading into what we're going over today. So this would have been a horizontal shift. I started with the blue and I ended with the red. So I had to move to the left 5 units. That's a horizontal shift. I could have also moved to the right, but that's just not what happened in this question, okay? I don't know if you guys are also noticing that if I'm moving to the left 5 units, you might have been thinking that that would have been a -5 because it's to the left 5 units. But if you look at the graph, it says +5. It's actually the opposite. All right, so keep that in mind as we jump down here and we look at our rule for horizontal shifting. So I'm just going to highlight this arrow because this represents a horizontal shift, left and right. And then as I read, it says that if I have a function where it has a plus value inside the parentheses, because if I'm horizontally shifting, that value is inside parentheses, just like up top. I'm not really adding that value, so I'm not really going to move it to the right. I'm actually moving it to the left. Okay, and then same thing here. If I have minus a value, I'm actually not moving to the left. I'm really moving to the right. Okay, it's the opposite sign. So one more time, if I look at the do now, it says +5 inside the parentheses. So if I'm inside, that means I'm moving left or right. You're not actually going to the right 5 units. You really moved to the left 5 units. All right, so just be aware of that. It's the opposite sign. All right, so these are the notes that you would need for today. If I look down underneath, it says, how would the graph of y equals absolute value of x be shifted in order to produce the graph y equals absolute value of x minus 3? Well, if I look at these notes that I created up top here, I know that if I'm inside some type of parentheses, down here it looks like I'm inside the absolute value sign. That tells me I have a horizontal shift. I'm going left or right. Okay, so because I'm inside those parentheses, I know that I'm going to be moving left or right. And if I look back at my notes from before, if I'm subtracting a value, I'm actually not moving to the left, I'm really moving to the right. So this tells me that I'm going to go to the right 3 units. Okay, they're taking just the absolute value of x, and then they changed it so it's x minus 3. All right, so they're taking the original function and moving it to the right 3 units. That's what this is saying. And then underneath is kind of the same question, just a different way. So it says, how would the graph of x squared be shifted in order to produce this new graph over here, x plus 6 squared? Well, originally, I had the graph of x squared. Okay, I know that if I have a horizontal shift, I should be inside either parentheses. I know this had the absolute value symbol there already for me. That was really nice. I don't see any parentheses here, but I can always add them on because it's really just x that's being squared. So instead of having just x inside the parentheses, now they have an x plus 6 inside the parentheses. So one more time, plus a value isn't to the right, it's actually to the left. It's the opposite. So this tells me I'm going to go left 6 units. All right, Cool. Let's flip and go to the next page. And this is very similar to yesterday. At this point, we're just practicing now all of the different tools that you've learned over the course of lesson 3 and what we just went over on the first page of lesson 4. So as I look at example 1, it says write a transformation where y equals the absolute value of x that's going to move it 5 units to the left. Okay. Well, if I think about what we just talked about on the first page, I know that if I want to go 5 units to the left, I'm going to just box this for a minute. That means I'm not actually going to write -5. I'm really going to put a +5 inside parentheses. Okay? So here, I don't have to create parentheses because since it's absolute value, those brackets are already there for me. So instead of writing y equals just the absolute value of x, I'm going to write it's the absolute value of x plus 5. That should be inside with it. And now I'm done. All right. If I look at number 2, again, it says write a transformation of y equals x squared. So I'm going to take this function and I want to move it 3 units to the right. So again, if I'm moving left or right, I have to be inside parentheses, and I'm not going to add 3, I'm actually subtracting 3. And this one is a little tricky because just like on the first page, there are no parentheses. There are no, absolute value symbols here for me. So I have to add those in. You always want to place it around x. All right, so now it's not going to be y equals just x squared. It's going to be x minus 3 squared. And I'm done. All right, so let's try 3, 4, and 5. So if I look at number 3, this was the original function, and I want to move 4 units to the left. If I'm going left or right, that means I'm inside parentheses, and it's the opposite sign. So I'm actually going to write +4. So inside these parentheses, because they're already there, I'm going to write y equals x plus 1. I'm going to keep what was there and then add on my +4. Now, the only difference with number 3 is that these are like terms, the +1 and the +4. So I can add those together and simplify this function. So it really just becomes y equals x plus 5 squared. All right, so this would be my final answer for number 3. Moving on to number 4. So again, it says I have this original function and I want to move it 2 units to the right. So again, if I'm moving left or right, I have to be inside parentheses with the opposite sign. So I'm not going to add 2, I'm really subtracting 2. Again, I already have these absolute value symbols here for me, so I don't have to add parentheses on, I can just start jumping in. So instead of writing y equals just the absolute value of x, it's going to be x minus 2 inside. And then this -4 just comes for the ride. And that's how you would solve a question like number 4. All right, and as we move on to number 5, same type of question. Here's the original function. I want to move 4 units to the left. Left and right tells me I'm inside parentheses, and I use the opposite sign. So I'm actually going to add 4. And if I look back at the original function, there's no parentheses here, and there's no absolute value symbol. So I have to add that on for myself. So just like we did in example 2, you always place the parentheses around x. So that's what I'm going to do down below because it's just x that's being cubed. So x is what's inside parentheses. So I'm going to rewrite that. Inside parentheses, now it won't just be x that's cubed. It's going to be x plus 4 that's cubed. And then this -1 just comes for the ride. All right. And now as we look at examples 6 and 7, these are a little bit more challenging because now we're combining what you learned yesterday with what I'm going over with you right now, okay? So as we read example 6, it says, which transformation of y equals f of x is going to move the graph 7 units to the left. So I'm going to box that. And 3 units down. I'm going to box this as well. Okay, so just like before, if I'm moving left or right, that means I have to be inside parentheses and I'm using the opposite sign. So it's not -7, it's actually adding 7. This is a little different. This is what we went over yesterday. So if I'm moving up or down, that's a vertical shift. And I just write what I see. So if it says down 3, it's just going to be -3. Okay, and this hangs out on the outside of the function. If I'm inside, it's left and right. And if I'm outside, it's up and down. All right, so now I just got to look at the graph over here, look at these choices, and see which one matches. So I'm looking for a +7 inside parentheses. So right now 3 and 4 are out. And now I need a -3 on the end. So 2 is out. That means choice 1 is our final answer. All right, and then it's going to be the same thing for number 7 here. So as I read number 7 again, it says if I have this original function, y equals f of x, I want to move it 2 units to the right, and I also want to move it 4 units down. All right, so I'm going to go ahead and just write this. If I know it's to the left or to the right, that means I'm inside parentheses with the opposite sign. And if I'm moving up or down, I just write what I see, right? -4. And now I have to see what matches here. So inside parentheses, I need a -2. So 1 and 2 are out. And on the end, I need a -4. So that means choice 4 is out. The answer was choice 3. All right. You can always check any of these questions that I went over earlier in the calculator to make sure that you got the right answer. All right, so I'm going to just go ahead and go over just number 1 really quick so I can show you the question with the calculator at the same time. So I know that the original function was y equals the absolute value of x. So I'm just going to go to my y equals, and I'm going to type in the absolute value of x. So I know I have to go to math, scroll over for absolute value of x. Okay. And you'll see that that will come up in blue when I graph. Okay, here we are. Now I'm going to go back, and underneath I'm going to type in that new function that we wanted, which was the absolute value of x plus 5. So I'm going to go to math again and type this in, the absolute value of x plus 5. Okay, I want to take our blue function, which was the absolute value of x, and I want to make it go 5 units to the left. Okay, if this works out, that red graph should be 5 units to the left of the blue. And let's check it. And I can see that that's true. So it looks like the blue is the one that we started with, absolute value of x. The x plus 5 really did move me 5 units to the left. So I know that I wrote this the correct way. Okay, it's just a way for you to check yourself if you have a calculator, or like I said, if you have this app at home. Okay, let's flip and go to the next page. If I look at number 8, it says the function f of x is graphed on the set of axes below. On the same set of axes, now I want to graph f of x minus 3. All right. This is a little bit different because I don't necessarily know what the graph of f of x is. I know what it looks like, but I don't know what the original function was. All right, so I can't use the trick that I just showed you on a question like number 8, but it has its own trick. Do you see how they already plotted some points for us? Okay, that's almost helping us, because if I see a number that's inside parentheses, well, inside parentheses tells me I'm moving left or right. Okay, and it's the opposite sign, so I'm not going to the left 3 units. That means I'm actually moving to the right 3 units. I'm just going to write this down here to remind myself that's what's happening. So for every point that's plotted, I'm just going to move it 3 units to the right. 1, 2, 3. Again, 1, 2, 3, and one more time, 1, 2, 3, because this guy's going to go off the graph, so I can't really plot him, so I'll leave it. And then I'm going to go ahead and just connect. And I'm done. All right. Make sure it has arrows at the beginning and the end, just like it did on the original function. Okay, cool. All right, moving on to number 9. So as I look down here, I'm just going to slide myself up here a little bit, okay? This was the original function. So this is nice because just like on the last page, they're telling us what the original function was. Okay, so I can always check myself if I need to at the end. So if I know that the graph was originally the absolute value of x, how is the graph being moved if I add a -2 on the outside? So f of x was really the absolute value of x. And now I'm just adding that -2 on the end. How is it changing from the absolute value of x to the absolute value of x minus 2? Well, if I'm on the outside, I know that moves me up or down. So I know that this would really be just down 3 units. So the graph is shifting 2 units down. And that was it. Okay. And then it's going to be the same thing for the rest of these questions here. So I know that if I'm inside parentheses, then I know that that moves me to the left or to the right. And this tells me I want to use the opposite sign. So I'm moving left or right here, and I have to use the opposite sign. Okay, so I'm not moving to the left 4 units. I'm actually shifting, or I'm moving to the right 4 units. Okay, if I look at C, it has 2 shifts. Inside moves me left and right. Outside moves me up and down. All right, so if I'm inside, I'm actually moving to the left 1 unit. And outside tells me that I'm then going up 2 units. Okay, same thing with D. If I'm outside, that tells me I'm moving up or down. So this would just be down 11 units. And then if I look at E, again, I have those 2 shifts. I'm inside and I'm outside. So inside moves me left or right. So this tells me I want to move to the right 3 units. The outside tells me I want to move down 3 units. All right, and there you have it. That was the whole lesson. Please make sure you guys are logging in each day, checking all of our lessons, and emailing if you need help. All right, miss you.